Okay, I take attendance first. 1 minute. Who is not here? One of you is not here, is it? Who? Okay lah. Later only I take the attendance lah. Okay. So before we start our class, okay, just now, one of your classmates asked to postpone our test. Okay, our test initially we plan to do it next week, next Tuesday. Let me finish it first lah. Okay. So initially we plan to do it by next Tuesday. Okay, coming Tuesday. But one of you saying that you have a lot of assignment and tasks due next week also. Okay. So he asked to postpone to next week. That means will be now is week what? Now is week 8, is it? Yeah, now is week 8. Okay, postpone to week 10. So is it all of you agree with that? The coverage no change. Okay, the coverage was still the same. The question, okay, like the coverage was still the same. The coverage no change. Okay, but the date will be postponed 1 week. Is that any objection? What is the coverage? Originally, I said where to where. Still remember? If not, I let me find. I also can't remember very well, but let me see. Lama, that's not. Let me think where I put it. Form C, Form C, Form C, Form C. Okay, never mind. I check from here. Cost timetable, my attendance, program. Okay. Your test A1, A2. I can't remember already. C, CO1, CO2. Complex variable. Okay. I'm not sure last time. Okay. I follow this one. Evaluate to simplify matrix. Let's see, not this one. 1 minute. This one is the last time one. 1 minute. Let me check. Okay lah. Uh, I think I just cover it. I just cover the chapter one. Okay, whole of the chapter one and the chapter two until what we learned last week. Okay. Where we stopped last week? Okay. We do until the Koleski method. Koleski method also include. That means stop before the numerical solution to a system of non-linear equations. Is it okay? I repeat again. Your test will be until page 17 of the chapter. This one is chapter 2. Okay. And then for tutorial, it will be until end of tutorial 3. Okay. Tutorial 1, 2, 3. Is it okay? Tutorial 1, 2, 3. Chapter 2. Until what we learned last week lah. Okay. So I think one of you just came in. I repeat again. Next week, your test will be postponed to next week. Okay, which is let me see. Now it's 8/22, 22nd of March. Okay, 22nd of March, and it will be cover of chapter one, whole of chapter one, and chapter two, first part of chapter two until page 17. Okay, which is LLT. Okay, so including tutorial one, two, and three. Okay, I write down. I write into the this one. Not this one. Sorry. Okay. 203 uh, to 1 plus 2 each. Okay. Row 1, 2, 3. Okay. So as I remember, I still owe you few classes. Okay. Later I will need it to do the to test out our progress, and but I will leave it after the assignment lah. Okay. When I think, are you okay to back to the campus, all of you, or anyone having any issue to go back to campus? Maybe after week 11 or week 12 lah, not so soon lah. So everyone okay? So after maybe after week 12 lah, after week 12, then maybe we can go back to the campus. Maybe we do like a whole day class. Okay, of course in middle I will let you to break lah. Okay, but we do a whole day class so that we can test up the progress lah. Okay, not okay Why leh? Because if in class face to face, we can do faster. Uh, Rather than I use a computer and then I draw here, draw there will be difficult also lah. But in class will be much faster lah. But again lah, is depend on your decision. If any one of you not okay, maybe I will still do the hybrid class lah. But if possible, I wish like you can have like face to face, because not much of you lah. In class maybe we sit separately lah, to be safe distance, something like that lah. It means fever. Sure not. Honestly, now I'm positive. Oh, same lah. I also fever. I also positive, but no fever lah. Oh, thank you, thank you. No fever lah, just a bit sore throat only. But I'm okay lah, no worry. Okay, so that one we discuss later lah. Not so soon lah. only if everyone okay lah. If anyone not okay, I will still do the hybrid class lah. For those who want to come, then you may come lah. But don't I do hybrid class? Everyone stay at home lah. If you want to stay at home, please let me know lah. We still can do more class if we cannot catch up the progress lah. Okay, no worry. Hybrid normally is according to your faculty lah. Hybrid is I do the actual class on campus, okay, at campus, and then if you want to come, you may come. If you don't want to come, you can stay at home. But I will still using computer to teach. That's all. The difference is one is you stay at home, one is you stay at class. But both of it, I also using the computer to teach. Any question, I also will answer through the computer. If you ask any question, I also won't use the board to answer lah. I will only use the pen or use a computer in order to answer you lah. So the difference is just your location. Clear? Okay, so that one later lah. That one later. Okay, we see how lah. Okay, but as I know, as I remember, I still owe you like 2 or 3 classes lah because of public holiday. Okay. Yes. Even your mask also don't take off lah. Okay. That one later lah. That one after your decision lah. Okay. After everyone is okay lah. Okay, so we continue first. Okay, so last week we had talked about the numerical solution to non-linear equation. Okay, so what is non-linear equation? Non-linear equation is something like x squared, y squared, x power of 3, y power of 3. As long as this one is more than power of 1, normally then will be a non-linear equation. That means your curve, it will be a curve. Okay, it won't be a straight line anymore. Okay, so normally we want to solve this kind of equation can by substitution, by elimination. By elimination is a bit tough for non-linear equation. Normally, in order to solve for non-linear equation, we use by substitution. Okay, but sometimes substitution is also not easy. Okay, for example, if you want to solve this one by substitution, okay, we get y equal to 1 minus ex. And then you substitute into the first equation, you have x squared plus this one 1 minus ex square equal to 4. Okay. This one, without using the program or any software, you want to use just calculator in order to solve this one, it's not easy as well. Okay, it's very difficult for you to solve when you have x squared and ex two together. Okay, so it's quite sometimes it's quite impossible for us to solve it manually. So what we're doing here is we try to use an approximate solution. What is approximate solution? We try to use a numerical solution. Okay, so few numerical solutions are given here. The first one is we try to plot the graph. Okay, we try to plot the graph and then agak-agak, okay, we roughly see that, okay, approximate where is the solution. Okay, the point that intersect is a solution. Okay, this is the first method. Okay, again lah, you want to draw is also not easy. So normally we try to use a computer in order to help us to draw. But again, let's say you don't have, okay, in exam, you don't have computer in order to draw. So how? We can use direct iteration method. But direct iteration method, okay, we get the equation, but the one thing is we have to has these two. What is the initial guessing? Okay, we have to start with some initial guessing, then only we can do it. But normally in exam, of course, you don't have computer, so normally we will tell you what is the approximate answer, and then you start from there. Okay, so I think this example we had mentioned last week, but I will just repeat again lah. Okay, so normally what we do first, now you have what? You have two equations. Okay, you have two equations because you have two unknown. So from there, okay, we try to get x from the first one. X equal to square root of 4 minus y squared. But don't forget, this one can be positive, can be negative. Why positive? Why negative? Because, okay, as you see from the graph, we have two places. Okay, where is this one and this one? Okay, so that means we record down. We record down can be this one, can be this one. Okay, you see your x can be positive, your x can be negative. So that's why we have positive, negative. Depend on which side you are referring. Okay, which answer you are referring. So when you are referring on this one, then you make sure you are using the negative. Okay, of course we have our method in order to test whether it is suitable or not. Okay, and then from here we can get y equal to 1 minus ex. Sorry, 1 minute. Let me get paper. Okay, so after I have these two, and then I have to put into the condition in order to check whether this initial guess is suitable or not. Okay, sometimes the initial guess not necessarily must be suitable, so you have to check. So how you're going to check? Okay, first you get your x, you get your y from the equation. Okay, you get your x, you get your y, and then what to do is now, okay, let's say I want to check this one. Okay, whether this one is suitable or not. So I differentiate with respect to x, differentiate with respect to y, and then I put in my x and y obtained. See whether it is less than 1 or not. If less than 1, that means this one is suitable. If not less than 1, then that means this one is not suitable. Okay, you have to test for both. Okay, so then what is a direct iteration method? Okay, just like what we learned before, the Gauss saddle. Okay, you just put in what is your x, what is your y from these two equations. Okay, from these two equations, and then okay, again this one is your r. Okay, this one you have to use back your xr, yr. But when you go to the second one, when you do the y, okay, make sure your x is changed by according to this one already. So this one is more like Gauss saddle rather than Jacobi, if you still remember. Okay, this is a Gauss saddle rather than Jacobi. Okay, so you put in your first initial guess, put in here, and then you get your x. Okay, you get your x, and then after that for your y, you put in your x, and then you will get your y, and continue until you get the last answer. Okay, until you get when the changing is less than 0.01, then you may stop. Then that one will be the answer. Okay, this one they take until 0.001. But in exam, the question doesn't mention the change is less than 0.01, then you may stop already. Okay. Okay. So 2 is when we find the solution near this one. Again we keep repeat the same question, same thing. Loan. Okay. This one, they suddenly change the equation. Okay, because now you why they suddenly change the equation? Okay, what they do here is just now is I get the y from here. Now is they get the x from here. Okay, they get the x from here, so that's why x is equal to ln of 1 minus y. So that's why you see here. They change the equation. Why? Okay, because here they doesn't write But if you still proceed with this one, if you still proceed with these two equations, okay, when you put in into the condition, you will find that it's not fit the equation. So that's why they change the equation, and then they found that they fit it. Okay, they can fit it, and then hence okay they can continue with these two, and hence with the initial guess, then they can get the answer. Okay, here they got right Okay, in case 2, if you try to find by x using this one, y this one, okay, then it's greater than 1. So that's why okay they doesn't use this one. They use a second equation to find the x. Normally we use a first equation to find the x, second equation to find the y. But not every time we will switch to the answer. Okay, so that's why here they change it. Okay, but the method is the same. Okay, if more than one you still keep doing, okay, you will get some point you get imaginary, or some point is diverge. You can see the difference is bigger and bigger, bigger and bigger. Okay, so that means the answer is not converged. Normally, if the equation you pick is correct, okay, from here to here, the difference normally was bigger than this one. The more step you do, okay, the difference will become smaller and smaller. When the difference is not getting smaller, that means something wrong. Okay, so now we try to do the tutorial 4. Okay, can you try to do the question 1? Maybe 5 minutes later I do also. You try to do first. You want question 1 and 2, you do one. Two do two later I left it to you. 2 is same as 1. Okay, so 2 I don't want to do. You do the 1 first. One ya. Untuk MAE 572, I think just combine saja lah, combine and then sebab satu lagi after week 7 I tak payah ajar saja kan untuk monitor saja kan. I takut lah nak ajar sama subjek yang ada. I sanggup nak combine. Kalau dia nak suruh I ajar satu subjek dengan dia, nanti banyak benda nak bincang lah. Tapi, tapi macam ni kan, kalau untuk MAE 572 lepas gabung dia akan I punya workload akan jadi 15 lah. 18 lah, bukan 15 ke? I nampak. Betul? Ya. Oh, so kalau lepas gabung akan jadi 15 kan? Kalau gabung MAE 572. Ya betul. So that's why gabungkan itu MAE 572 lah. Ya, tak satu subjek dengan Prof lah. Ayo, bos itu nanti banyak benda nak discuss lah. Ayo. Combine lah. Ya, betul. Ya. Sebab lepas tu memang itu SME tak payah ajar kan. Just monitor saja kan. 啊哦，就不啦。哦okay, boleh. You try to arrange lah, tapi I memang takut nak. I sanggup dua kelas gabung lah. Ya. Okay ah, boleh ah. Boleh boleh. Hmm, boleh boleh. Tapi kalau boleh first 5 week memang gabung lah. Kalau ada aktiviti apa-apa ke itu masa sudah online lah. I boleh arrange lah. Itu senang. Ah, okay. Okay, thank you. Okay, so we have a look. Question one. Question one is a bit similar to your example in your notes. Okay, so we try to do. Okay, so we have let's say we start with the easy one. Okay, we try to start with the easy equation. Okay, don't direct you start with y equal to 0.9 plus x and then run with it. That one will be very difficult. So what it means we try to start with x equal to we get the x from the first equation. Don't get the y. Okay, we try to see whether can work or not. So ex minus 0.9. Later we check whether it can work or not lah. Okay, and then if you get the x from the first one, then that means you have to get the y from the second one lah. So that means your y will be cubic root of x squared minus 0.1. Okay, x squared minus 0.1. So okay, now we try to see whether this one can work or not. Okay, so first we try to differentiate with respect to x. Okay, so del f del x will equal to ex. Del f1 del y will be equal to 0. Okay, and then del f2 del x equal to a. Oh, okay, okay. Sorry, my mistake. This one should be y, but I take it as. Sorry, my mistake. Okay, so this one is ey, So ey. So this one will be 0. This one will be ey. Del f2 del x. Okay, in order to differentiate this one, okay, you just assume this one is power of 1 over 3. So we take down 1 over 3. And then this one inside still remain the same. But the power minus of 1, that means will be negative 2 over 3. And then inside there will be 2x. And then del f2, del y will be 0 lah. Okay, so now we try to check. Okay, how are you going to check? You just use back the formula here. Okay, not formula lah actually. Why? Same thing. Okay, you just use back this one lah. The same thing here lah. Okay, you try to see whether it's equal less than 1 or not. Okay, so this one, when you have del f1 del x plus del F1. You have to remember, you have to put the modulus, because sometimes you get negative. Sorry. Del Y. Okay, just like what we have here. Okay, plus together. So the first one will give us 0. The second one will give us E. Okay, 0.2. They said 0.2. So E 0.2. Okay, E exponential of 0.2. I get 1.22. Okay, this one I get 1.22. So unfortunately, E 0.2, I get 1.22. Unfortunately, this one is greater than 1. So that means, okay, we cannot use this one in order to proceed. Okay, if we use this one in order to proceed, then you might will get something like this. Okay, because it's greater than 1. Okay, so let me check. Correct. So that means I cannot use this one. So that means I have to use another one. Okay, so try the another one. Okay, I try the another one. So that means I will have EY. That means I try to get the Y from the first one lah. So that means I will have Y equal to 0.9. Oh, sorry, ln of 0.9. Ln of 0.9 plus X. This one is Y. Okay, I get the Y from the first equation, and then I get the X from the second equation. Square root of 0.1 plus Y cubed. Okay, so now we try to differentiate. Okay, df del f1 del x equal to 0. Normally it will be something like that lah. Del f1, this one if is x equal to something of y. So that means your x must be 0 lah. Okay, no need to check one. Del y, okay, this one will be 1 over 2 we take down, and then 0.1 plus y cubed power of negative 1 over 2. Okay, and then everything times 3y squared. Okay, and then your del f1, del f2, del x So sorry, I does not found that. Thanks for reminding. Okay, so we continue. So next one, 0.9 plus 0.3286, ln of the answer, 0.2059. Okay, so the second times will be square root of 0.1 plus 0.2059 cube. So 0.3297. So you can see the difference is getting smaller and smaller. Okay. Ln of 0.9 plus 0.3297. So this one will be 0.2068. Thirdly, square root of 0.1 plus 0.2068 cube. So this one will be 0.3299. So the difference is very small already. Okay. So no difference between, if you take 3 decimal, no difference between 2 and 3. Okay. And then the third one, ln of 0.9 plus 0.3299. So this one will be 0.2069. So that means now your answer is what? Your answer is this one. Okay, because not much change already. Okay, the changing is less than 0.001. So no point you do again. Okay, if the approximation is very, I mean the small difference is very small already. Okay, can be negligible. Okay, so this one will be 0.3, or you have to round up, so 330. And then this one, 0.207. Okay, have a look. Any questions before I proceed again? Quiet means no questions, ah? No question, then I proceed, ah? Okay, so we go back to here, come back to here. Okay, so Newton-Raphson method. Okay, so Newton-Raphson method, so similar to the iteration method, okay? Direct iteration. Direct iteration is we try to get the answer for nonlinear equation. So this one also the same, okay? But the method a bit different. Okay, so now we have a look. Okay, so let's say we have these two equations. Again, now we have two equations. But you have to take note, this one is we make it into equal to zero. That sound no. That's not necessary. Okay, your function one can be not necessary must be equal to zero. Function two also, but this one you have to make it into something equal to zero. Okay, and then let's say I have x, y, rs is an actual solution. Then we have actual solution. That means you put into this one x, y into the rs. Then you also should get the zero. Okay, so we direct jump to the formula lah. This one the explanation you can have a look lah. Okay, we direct jump to the explanation. You can see here if Newton-Raphson, okay, you can use these two formula in order to get the x and y. Okay, by using the Cramer's rule. Okay, Cramer's rule is something with the matrix. Okay, if you are interested, you can have a look lah. But here I jump it lah. I direct jump to the formula. Okay, so now let's see how we're going to use this formula. Okay, in order to get the answer. So you have to remember you have two equations. You have f, you have g. So now you have two equations here. You have f, you have g. But with the condition, you have to move it to the in front. Move to the in front. Move to the in front because the condition is 0 and 0 at the back. Okay, 0 and 0 at the back. So that means that one will be your f, will be your g. Okay, and then you have to differentiate with respect to y. Okay, so you differentiate with respect to y. The first one you differentiate with respect to y, you have 2y. So that's why 2y here. This one you respect to y, you have 1 here. And then this one is when you differentiate with respect to x. So you have these 2. Okay, this one is the same lah, y lah. Okay, so this is the formula in order to get the x. For y will be similar. Okay, will be similar, but fx, gx, fg, fy, gy. But it's a similar thing lah. Okay, so what you have to do here, you just put in x0, y0. They tell you x0, y0 is what? Is 1. Okay, it's 1 and negative 1.7. So 1 and negative 1.7. So you put inside. Okay, so you will get your x1 and also your y1. And keep continue, you do the y2, x2, and then y2. This one, you have to take note. This one is not power, but it just mentioned which r only. Okay. This one until 3, but not means power of 3. Okay, just r equal to 3. Okay, so keep repeat until you found that your answer is small enough. Okay, doesn't change much. This one compared to this one and this one doesn't change much. Then only you can stop. Okay, so now we try to do. Let me see. Okay, number 3, I will leave it to you. Try to do number 4 now. No, number 4, sorry. Number 3 lah. Try to do number 3. This one you don't need to sketch. Let me see. I don't need you to sketch lah. You direct start with the 1.8 and negative 2.7. No need to sketch. You direct jump to here by using these two. This one and that means you start with 1.8 negative 2.7, and negative 2.6, and negative 4.4. You start with this one first by using the Newton-Raphson in order to get the answer.
你用丢脚步进去那个桶是吗？
不知道。
我昨天洗了。那我给我忙一次吗？
他都出来拿了。
啊？
他自己出来拿进去了。 Okay, so now have a look. Honestly, if you ask me to sketch, I also cannot sketch like just give me two equation and then that sketch directly. I also need computer to help. Okay, so this one, don't worry lah. I won't ask. The things I cannot do, I won't ask you in exam lah. Okay, unless you can use computer lah. Okay, but for this time, will be the actual one, is it? So you cannot use a computer. So no worry lah. I won't ask you to sketch in your exam. Okay. So now we have a look. So again, you try to arrange everything to in front. As cube. Okay. Let's say we put one as because you see our formula we need f, we need the g lah. So let's say the first one will be the f lah. So f will be sorry 1 minute. Okay, f equal to, we move everything to in front, so x cubed plus 2y squared minus 21 equal to 0. So your g will be x squared plus 2y plus 2 equal to 0. So in order to get your x, okay, in order to get your xr plus 1, okay, by using Cramer's rule, so it will be your f and g, okay, up to you lah. You want to write the long one or you want to write the fg only, up to you lah. Okay, so this is your f, and then you need the fy gy. Alamak, I forgot this one. Okay, they use XR, YR. This one, okay. Okay, since they use XR, I just follow lah. So this will be XR minus 1 minus, okay, following this formula lah. So this one, the differential with respect to y, okay, in order to get x lah. Differential with respect to y, I have 4y and 2. This one, differential with respect to x, 3x squared. And 2x. Y will be the same lah for y and 2. Okay, so this whole thing will be r minus 1, power of r minus 1. And then yr, 1 minute. Okay, so this one will be yr minus 1 minus this one that I need again. Okay, so this one with respect to x, I have a 3x squared, 2x. Okay, so now we have the equation like this. Okay, so now we try to do okay. So okay, so I have when I want to find the x, okay, so now I know that my x0 equal to 1.8, my y0 equal to negative 2.7. So by using these two, I try to find the x1. Okay, so what would be my x1? Would be 1.8 minus of, sorry, what? Okay, 1.8 minus of, now we put in, okay, 1.8 negative 2.7. Okay, so 1.8 cube plus 2y squared, 2 answer square, minus 21. Okay, and then everything times this one will be When you calculate for y, no need to calculate again because everything is in the x already. So continue the same thing for x2, y2. Try to continue. Okay, so we continue. Okay, so x2 will be 1.8498 minus solve. Okay, so again now we have to refer to this formula. Okay, x cubed plus 2y squared minus 21 plus 2y squared minus 21. I get 0.0134. Okay, and then this one will be x squared plus 2y plus 2 plus 2y plus 2. Wow, I get a very small number. 0. Sorry. Write me if you found any mistake. 2.5, sorry. 0.0026. Okay, and then 4y and 2. 4y and 2. Okay, sorry because I use a mouse, so a bit slow there. Okay, so this one will be 3x squared and 2x, 3x squared and 2x. 2x equal to negative 5.4192. This one. Alamak. Sorry. Thanks for remind. Thanks for remind. I get the 2y already. So sorry. Thank you. Should be positive. So this one I get 1.8488 lah. 89, sorry. Okay, so what we see, if you take this one and this one, the difference is less than 0.01, so it's okay already, even in your exam. It's only 0.0009. It's less than 0.001, so it's very small already. But still depend on your Y lah. This one I direct use this answer lah. I don't need to write anymore. Okay, so since the difference is very small, so I will take my X as 1.8489 and then Y will be negative 2.7092. I trust you do the second one also be the same lah. Another set of solution will be almost the same. Okay, so is it okay if I stop here for these questions? So for these questions, another set of solution I left it to you. If you can't get it, only let me know. Okay, so I proceed first. So this is called Newton-Raphson method. Okay, Newton-Raphson method in order to solve the nonlinear equation. Okay, so we also can use this Newton-Raphson method in order to proceed with the optimization problem. When we say optimization problem is something with maximum minimum. Okay, something with maximum minimum. So how to do? Okay, so normally you were given an equation like this. You were given an equation like this. So what you do is you differentiate with respect to x and then equal to 0. And you differentiate with respect to y and then you get 0. So that means now you will have two equations. Then by normal, using the Newton-Raphson equation, okay, solve these two equations. Okay, so we have a look. So when you differentiate with respect to x, you have this one. When you differentiate with respect to y, you have this one. But it can be simplified y equal to x or x minus y equal to 0. So that means now you have two equations. One is this one is this one. So in order to solve it, what is this? Let me see. Okay, yeah, we direct start from here. This one is by using dxy, by using by finding the approximate answer lah. Okay, by finding the approximate answer. Okay, this one no need to care about it. Okay, you just direct proceed here to here. Okay, so now I know I have to start with 0.9, 0.9. Okay, so 0.9, 0.9. So now I have two equations, move everything to in front to get equal to 0, and then get two equations, xr and also your yr, and then put in 0.9, 0.9, then you will get your answer. But again, you might need to do several times in order to get the answer. Okay, when the change is small enough, then okay, this one will be the final answer. Okay, so this one will be your final answer. Okay, so now we try to do the questions 4. Yeah, try to do the question 4 by using Newton-Raphson method. It's similar to 3, just the problem is how you're going to get the equation only. Question 3 that direct gives you the equation. Problem 4, you have to get the equation by your own. Okay, try to do it. Okay, so we have a look. Basically, it's the same lah. Okay. I mean, yeah, method is the same. Okay, so we differentiate with respect to x. I have 4x cubed minus 4xy plus 2x plus 2y minus 1 equal to 0. I check again. 4x cubed minus 4xy plus 2x plus 2y minus 1 equal to 0. Differential with respect to y, okay, minus 2x squared plus 4y plus 2x minus 1 equal to 0. Okay, so let this one equal to your f lah, and then this one to your g. Okay, so your xr will be equal to xr minus 1 minus of, okay, this one, wow, very long. And then according to the formula again, after you have, sorry, after you have your f and g, fy, gy. So this one with respect to y, I will have negative 4x plus 2. This one with respect to y, okay, I will have 4. Again, correct me if you found any mistake. Okay, this one with respect to x, I will have 12x squared minus 4y plus 2. With respect to x, negative 4x plus 2. This one will be the same lah. Negative 4x plus 2, 4. The y will be yr minus 1 minus of this one. Okay, and this one. Divide by whole thing. Okay. Yes, anything wrong? Initial point always given, yes. Always will be given, no worry. Okay, so I continue. So my x0 equal to, but again 0.3 and 0.1. So this one is 0.3. This one will be 0.1. The rest will be the same as just now, but this one I finish it. Okay, so x1 will be 0.3 minus of, okay, so 4x cubed. So 4x cubed minus of 4xy plus 2x plus 2y minus 1. Again, correct me if I did any mistake. Negative 0.212. Okay, and then negative 2x squared plus 4y plus 2x minus 1. Negative 0.18. Okay, and then negative 4x plus 2. 0.8 and 4. 2.68. This one also 0.8. 0.704. 10.08. 0.3698. Okay. Sorry. proceed to X2.